Hey guys, thanks for watching. This is part 3 of the section about lines. And so far we have discovered that for a function of the form y of x equals mx plus c, turns out that actually, this thing does make a line. This m determines the slope of the line and it's called the gradient. This c tells us where this line is going to intersect the y-axis, and it is called the y-intercept. For example, if I draw the graph x, y, if I draw the graph of the function y of x equals negative a half x minus 1, I know immediately that it's going to look something like this, where if I pick any point here, any point on the line, any 2 points on the line, and then I calculate this distance, which is called the rise, and this distance, which is called the run. If I divide rise by the run, I'm going to get the gradient, which is negative a half. And I also know that this point here is negative 1 because it has x coordinate 0. And when I put 0 into the function, I'm going to get negative a half times 0 minus 1, which is, of course, negative 1. Okay, so I immediately know where my line is. I know what it looks like. Notice that the rise here is actually negative because as we increase x in the run direction, y actually decreases, y goes down. All right, so those are lines. Well, those aren't actually all the lines. They're almost all of them. There's a couple of special cases to consider. Let's first consider a completely horizontal line. So this is the x-axis, this is the y-axis, and I'm going to draw a line that's, didn't do a very good job there. I'm going to draw a line that's parallel to the x-axis. So it never gets any closer to the x-axis. This distance here is constant. And I'm going to say it cuts the y-axis at, I don't know, 3. Doesn't really matter. What is this line? What on earth is this line? How do we write it? Well, it's actually just the line. It's actually very simple. It's just the line y of x equals 3. Because it doesn't matter which x point I choose, it's always going to give 3 as the output. That's what that line means. So it's simply y of x equals 3, or another way to write it is y equals 3. Because everywhere along this line, y is equal to 3. So that's completely hard. That's how we write the equation, if you like, of horizontal lines. Other one we mentioned earlier was vertical lines. Vertical lines. So this is the x-axis, y-axis. Okay, now how about this line here? This is vertical, which means it's parallel to the y-axis. This distance here stays the same this time, and let's say it cuts the x-axis at 3. How would we write the equation for this line? Well, it doesn't really depend on y at all. And at every point on the line, we know that the x-coordinate is 3. So let's just call it the line x equals 3. So when lines are completely vertical, that means parallel to the y-axis, wherever the line cuts the x-axis, so if it cuts the x-axis at 3, for example, as it does here, we call it x equals 3. So that's the equation of vertical lines. Something to notice about them, though, they're not functions. They fail the vertical line test. Remember, vertical line test says if I draw a vertical line anywhere like that, it should intersect the function only once. Well, if I draw a vertical line down here, I'm actually going to get every single point on the vertical line I just drew intersects our mapping, and so then it can't be a function. So whenever the line is vertical, it's a completely special case. It has nothing to do with y. It's just x equals whatever the intersection with the x-axis is. And it doesn't depend on y at all. And more importantly, it is not a function. Okay. And, well, can you think of any other lines? No, I can't think of any other lines. Every single line we have now covered. So every single line can be written in the form y of x equals mx plus c, or x equals a, where the vertical line cuts the x-axis at a. Has to be one of those forms. Yes, even if the line is horizontal, perfectly horizontal, I mean parallel to the x-axis, it still has this form, because if it's, say, y equals 2, that just means that the gradient is 0. So it's still in the form y of x equals mx plus c. Alright, we have covered all the lines. What's next is to maybe play around with them a little bit. So something you may have thought about, or maybe not, I don't know. Two lines will almost always intersect each other at some point. So if I've got any two lines, so I've got this line here and maybe this line here, they're always going to intersect each other at some point. They're always going to intersect at some point. And they can only intersect at either one point or every single point if they're the same line. But that's kind of let's not pay attention to that. Let's just suppose they're two different lines. If they're two different lines, they can intersect at most one point. How is it possible that they don't intersect at all? Well, if they don't intersect at all, it must mean that they are parallel. And remember, what I mean by parallel is that the distance between the two lines never changes. And if they are parallel, then that means that they have the same gradient. They have the same gradient, because remember, the slope is determined by the gradient, m. And if the two lines are parallel, that must mean they have the same slope and therefore the same gradient. So we know that line 1 has the form y equals mx plus c1, and line 2 has the form y equals mx plus c2. How do we know what c1 and c2 are? Well, c1 and c2, these give us the y-intercepts. So this value here must be c1, and this value here must be c2, because it's where the lines intersect the y-axis. The y-intercept is what they're called. All right, so given two lines, how do I determine exactly where they intersect each other? Okay, so let's do like an actual example with numbers this time. Let's take the line, I don't know, y equals, better not screw this up, y equals half x plus 1. Yeah, that's fine. Y equals half x plus 1. So I know that this number is 1. And this number must therefore be 2. Because rise over run should be 1 over 2. Sorry, not 2, negative 2. I mean this distance here should be 2. Okay. So that's our first line. Our second line, I'll choose a different color. Let's suppose it's just the line yeah, okay, whatever. Y equals 2x. I know this diagram's a little badly drawn. And I want to find the value of the intersection point. I want to find where these two lines intersect. So I want to know what the x coordinate here is, and I want to know what the y coordinate here is. Well, so let's call this y1 to be original. Okay, so, and this is, again, let's call this x1. So something we have observed is that at this point, at this coordinate, y1 is the thing that comes out of both functions when we put x1 into it. So y is the thing that comes out of both functions when we put x1 into it. So we know that y1, I use black, we know that y1 is equal to 2 times x1, and we know that y1 is also equal to 1/2 times x1 plus 1. Because if I put x1 into this function, I get y1, and if I put x1 into this function, I get y1. So if y1 is equal to both of them, then they must be equal to each other. So we know that, therefore, 2x1 is equal to 1/2 x1 plus 1. And now we can solve it just using regular algebra. So we subtract half of x1 from both sides, and we get 1.5 or 1.5 x1 is equal to 1, and therefore x1 must be equal to 1 divided by 1.5, dividing both sides by 1.5. And 1 divided by 1.5, another way of expressing that, is 2/3, 2/3, because we just times both sides, both the top and the bottom rather, by 2. And 2 divided by 2 is 1. So now there we have it. So our x1 coordinate, it turns out, is actually 2/3. Now how do we find our y1 coordinate? Well, we have a choice. We can choose whichever function we like. We know that y1 comes out of this function when I put in x equals 2/3, and y1 comes out of this function when I put in x equals 2/3. I'm going to use this one because it looks a bit easier. So let's put x equals 2/3 in, and we get y1 is equal to 2 times 2/3, and that's equal to 4/3, or 1 1/3 if you like. So y1 is equal to 4/3. So that's how to find the intersection of two lines. You actually just have to set their equations equal to each other. Let me do another quick example. I want to find the intersection point of the lines y equals 2x plus 7 and y equals 17x, yeah, sure, minus 12. Well, I know that when they do intersect with each other, the two y coordinates are going to be equal at the x coordinate for which they intercept. So to find that x coordinate where they intercept, I just set the equations equal to each other. So that gives me 2x plus 7 is equal to 17x minus 12. And now using algebra, add 12 to both sides, subtract 2x from both sides, you get 15x is equal to 19. 12 plus 7 is 19. And therefore x is equal to 19 divided by 15. And what is that? I don't know. 1 4/15. So let's just leave it like that. I think it's easier. 19 is a prime number anyway, so we can't simplify the fraction. All right, now what's left to do? Let's go ahead and find y. We know that the x coordinate where these two lines intercept, whatever they look like, we know that the x coordinate where they intercept has to be 19/15. So let's find the y coordinate where they intercept by putting 19/15 into either one of these functions. Doesn't matter. I'm going to pick this one just because it looks simpler. So y is equal to 2 times 19/15 plus 7. 2 times 19 is 38, so y is equal to 38 divided by 15 plus 7. I should have chosen simpler numbers. And you can type that into your calculator and find out what that is. I don't know. I can't be bothered to work it out in my head. Okay, so that's how to find the intersection points of two lines. One more video on this section after that, and then we'll call it quits for this section. Thanks very much for watching. Don't forget to check out the notes. I actually forgot to include the intersection part of two lines in the notes, but it's a very important thing to understand, so make sure you get your head around that. Maybe I'll update it later, so if you see it in there, that means I've updated it. Anyway, thanks again for watching. Check out the notes, have a go at the exercises, and I'll see you for the next video. One more section on lines, and then we'll move on. Thanks very much. Take care.